Learn about force of cohesion, force of adhesion, and viscosity. So starting with the force of cohesion, what is it? What is it? A force of attraction between the molecules of the same substance is called cohesion. What does it mean? Like if we have a beaker, we have a fluid in it, let it be water, but you can take juice or wine or anything else, but let we take it water. Okay, these are the molecules of water, and they attract each other, that they are the molecules of the same substance, and they have the force of attraction between them. This force of attraction is known as cohesion. Now we must move on to the adhesion forces, like the force of adhesion, that's the same thing. So the force of ADHESION, the force of adhesion. What do you mean by that? That the force of attraction between the molecules of different substances is known as adhesion, or is called adhesion. This is the molecule of the beaker, and these are the molecules of water, and the attraction between them is known as the force of adhesion. The example of the force of cohesion is like two droplets, okay, they're touching each other, they get converted into a big droplet. That is due to the force between them. Okay, so these are the force of cohesion that converts it into a big droplet. So examples for the adhesion is in front of you, like I am writing with an ink. So ink has some molecules, and the whiteboard itself is having the molecules, and the attraction, due to attraction between them, the ink is stuck to it. So even if I tilt it or rotate it, the ink will not get off because of the force of adhesion. To the next thing, that is viscosity. And brushing up again, cohesion is the force of attraction between the molecules of same substance, and the adhesion is the force of attraction between the molecules of different substance. Okay, and now moving on to the viscosity. Now what is viscosity, as what is the what we call definition of viscosity? That is the property of a liquid by virtue of which it opposes the relative motion between its adjacent layer is known as viscosity. So now what is layer? We generally, like, it's a beaker, it's a fluid, so it's a layer 1, layer 2, layer 3, until the bottom. What this layer is, we generally believe that the what we call it fluid is divided into layers. Like there is the force of friction between the layers that we call viscosity, that we are going to discuss in brief, or we'll learn in in a good way. So that's it. Like if we have a book, okay, we have a book over it like this. I know my drawing is too good, but try to understand whatever is drawn. Like it's a book, like PHYSICS, physics books. Okay, the force of F is applied on it. Then what will happen? It will move with the velocity of v. Why? Because there are the molecules over here. That is the first layer of the fluid that will be attached to the book by the force of adhesion. So, and when the force F is applied, it will move with the velocity v, and these will stick to it. This is by no slip condition. It is experimentally verified that this first layer that it gets stuck to the surface, and many people will ask, it is force that is mass into acceleration, then why it doesn't move with an acceleration? The reason is the second layer will apply a cohesion force on these the first layer, that is, and this will act as like friction, like F. So F, the same F would be the velocity for the force for the second layer by the Newton's third law. Okay, and due to the same reason, these molecules at the bottom will also not move. They will remain at rest due to the same no slip condition, because the beaker is at rest. So due to adhesive forces, they will stick to it. And now I'm gonna make the streamlines of velocity of the layers. So it goes like this. So what we call this point here, the velocity is 0, and here the velocity is maximum. It keeps on decreasing and decreasing and decreasing, and that's it. And now we're gonna derive the coefficient of viscosity. What is the coefficient of viscosity? It tells us about how viscous, how thick that substance, or how thick that fluid is. And we're gonna do it by force is proportional to B, more the velocity, higher the force, more the velocity, and is proportional to A. What is A? A is the area of the book that is in contact with the water, especially not the area of the whole book, only the area of which is in the contact. So that's it, and is inversely proportional to D. What is D? D is the depth, and depth is why it is inversely proportional to depth is because as it has more depth, there will be large number of layers. More the deep it is, more the number of layers. So it will like it's offering resistance. So more the layers, more the resistance. So it is inversely proportional, and F is equal to minus eta VA by D eta. So this minus only shows that it's opposite, OPP, opposite in nature, and this eta is coefficient of viscosity. This formula is of the great importance. Okay, so you must remember that formula. And another thing, if you want to have feel of what viscosity is, like in the ocean we have very clear water. Okay, we have very clear water, but the surface or the bed of sea have a lot of impurities, like the fossils of the marine animals and the mud, and it doesn't mix. It's the proof that the velocity at the bottom is nearly zero. Why? They doesn't mix with the water, and it doesn't destroy your summers. You enjoy your summers with the clean water in the sea and enjoy it.